Illustrative Chemistry's summer webinar series giving overviews of chemical database service resources. Today's webinar will be discussing SPRESIweb, which is a chemical structure and reaction database. It will be presented by Valentina Eigner-Pitto from InfoChem, the suppliers of SPRESIweb. Over to you, Valentina.
Well, okay, hello, I'm Valentina. I'm responsible for marketing at InfoChem. Have been for the past 9 years now, and well, I'm happy to give you a short overview about the SPRESIweb database. Just to give you an idea, I have a couple of slides that introduce the database, SPRESI, and then I will show you with the live demo how you can really use and work with the database. So SPRESI is a structure and reaction database that focuses on organic synthesis. It contains now 5.62 million molecules and 4.34 million reactions, abstracted from nearly 700,000 references and patents. The database can be accessed via the internet, as you do, and intranet, but it is also purchasable as the SD and RD files. A couple of words to the history. Why does such big database exist? Well, in the 70s, the Vinity Institute in Moscow, together with the Zentrale Informationsverarbeitung Chemie in Berlin, starting to build an electronic structure and reaction data collection. They called it SPRESI. The idea was to create a counterpart to the activities that Cass and Beilstein started in West, which means that by abstracting the literature, the Vinity and SICK really tried to keep the data similar to ones of the analog products on the market. Since 1990, InfoChem has the rights to distribute these data and has agreements to receive regular updates from the Vinity Institute that does continue to collect these data. What we do is to process them, develop the application, so SPRESIweb, and the software tools to use the data, and yes, we always have updates to the SPRESIweb database. Now, the data are abstracted in Russia, so somebody could think or ask which are the journals from where the data comes from. But if you have a look here, these are the most quoted journals in SPRESI. You can definitely see all the common journals or representative journals for organic synthesis. We do have one Russian organic synthesis journal, but this, I mean, in these 8 most quoted journals, this can be also interesting because it could have new ideas. At the moment, with version 2.13 that we launched in July, we cover the data from 1974 to 2012. We normally have 2 releases per year, but we do always have a delay in the upload and update of the database. It's 6 months to 1 year, and we will never be able to close this gap. So we can arrive at 6 months maybe, but not much less, because we really need the time for the processing steps and for quality control. For what concerns the architecture, it's quite easy and simple and direct. The database is stored on a server here in Munich. The user only needs to have an internet access to search the database. What we also do offer is SSL, so a secure socket layer for who is concerned in having queries going out without encryption in the internet. Normally we do not put it as default because of course the encryption does slow down the search possibility. So this is the homepage of SPRESIweb. Actually, I have learned that the people accessing SPRESIweb from the chemical database services actually go directly to the first page. So this is what I would like to show you now with a live demo. This is the page that you have seen now. We have a couple of possibilities. You have an automatic login. Of course, we also have a password login. This is the secret socket layer I was talking about. So just let me log in. I will do it with a username and password. And here I am. So this is the starting page of the SPRESI database. Here you can see where this funny name comes from, so Speicherung und Recherche strukturchemische Information, which is the German for storage and retrieval of chemical structure information. In this first page, you can see three main areas. This one here is the quick search. We can have exact or substructure quick searches, and also the links to the forms for molecule reaction and reference search. Up here, you also have some links to the homepage of SPRESI to start a new query, to have a look at the history of your searches, help, and log out. And here on the left side, you also have links that take to the different searching forms. To STS. STS is a synthesis planning tool. I will talk about it and show an example later on. Query and hit list management is unfortunately possible only when you're logging in with a username and a password. Of course, if you have an IP login, it is impossible to save queries and store them. It is nevertheless, of course, possible to download hit lists. So let us start with a molecule search. So I can click here or here. It's the same. I will always start from this form, this new molecule query form. We have a quite broad list of possibilities in text search. So we have a basic index. As you can see down here, basic index searches the name, trivial name, and molecular formula. We have the possibility of searching for supplier, physical properties, molecular properties, reference properties, and so on. Of course, we have the Boolean operators, so equals, contains, begins with, so on, and we can combine. We can combine text searches, and we can also combine structure searches with text searches. For what concerns the editors, we have as a standard IC edit, so the editor developed at InfoChem, but we do also support ISIS, DrawSo, MDL, and what it's called now, but it is supported, and ChemGrow by getting plugins. For what concerns the search operators, we have a certain number of search operators. So what you would expect to find, such as exact search, substructure search, similarity search. We also have isomer, tautomer, and parent search. or a flex match, which, as you can see here, this is this quick help. It's always activated here if you have it in and otherwise not. So a flex match will look for all these exact structures. Innovative and only present in InfoChem products is the all-in-one structure search. Again, as you can see down here, a all-in-one structure search performs an exact or flex match, then a substructure search, and then a similarity search. At the end of this search, we will have a ranked hit list. I will show you an example in a minute. Just the last two important parts of the molecule search form. Here you can choose if having a detailed or a compact hit list. You can choose how many hits per page you want to see. You can order the list, and you can also choose to see the substructure in the hit list. So this will be highlighted in blue. Here we also have another link. This link goes to a document which describes in an extreme detail how queries can be performed. So for example, how can I define lists of halogens in a query, and so on. So this is definitely an advanced document, but who wants to have more details about how does the search engine work can have a look at it. Or if somebody has problems in defining the query so that they get the right hits, again, this can be, here you can find instructions to solve the problem. So now I will just start and show you an example. Actually, I will draw a structure, a very complicated structure. I suppose none of the people listening to this webinar have never seen such a chemical formula, of course. So I click on the search button, I perform the search, and of course everybody knows I will find aspirin. So this is a view of the compact hit list. I had chosen 12 hits in a compact view, and you can see here I've performed an all-in-one search. So I have exact isomers, tautomers, and here also the highlighted substructure. Now I will just change slightly the hit list view and perform the search again to show you how the all-in-one search operator works and what we can get as an information from it. So as I said, the hit 1 of an all-in-one structure is an exact search. This is exactly what I was looking for. The hits 2 to 9 are isomers. So I have them with deuterium and with another isotope of carbon and so on. On the hit 10, the hits 10 to 16 are parent searches. We always have the soles. And starting on the 19, we have flex match, which means we have also the chiral and so on. From hit 29, we start with the substructure. So again, here you can see the substructure of aspirin highlighted in blue and the rest of the hit. And of course, after the substructure, we will have the similar the results for similarity search. When I perform an all-in-one search, I always have 100 hits. This is because, of course, otherwise we would get all the similar structures or the similar reactions. This would just enhance the searching time. Up here, you also have commands to work with the query. So, as I said, query and hit list can be saved when one is using a username and password login. But we can modify queries, we can start a new query, and so on. We can switch to reference. When we click on this button, all the hit list will be switched in a reference view where not the molecule, but the references are shown. This is how a detailed hit looks like. As you can see here, or as maybe you have noticed before, sometimes molecules are highlighted in green. Green highlighted molecule in SPRESI is always a commercially available molecule. So we have different suppliers that supply us aspirin. Let us choose Sigma Aldrich. Of course, we are now leaving the interface of SPRESIweb. We only have a link to the supplier, and so the link goes directly to, in this case, different possibilities that Sigma Aldrich offers to buy this compound. The same will work with all the other suppliers. If we don't have a direct link to the compound in the supplier catalog, we always link to the home page of the supplier. Here you can see also everything what is red in SPRESIweb is a hyperlink. So we have hyperlinks to more names and synonyms of aspirin. And of course, here you will recognize more than one, acetaminophen and so on. Now, yeah, of course, I'm saying aspirin the whole time. Of course, I'm talking about paracetamol. I hope you excuse this lapsus now. Here we have another link to keywords. Keywords are a very interesting attribute in SPRESIweb. These keywords have been given with from the abstractors. We have a ranking of keywords. So when the abstractor gets the paper and has a new structure, has also a list of keywords that he can assign to the compound. For example, if we get paracetamol, it has, of course, it is a pharmacological agent. And for example, I can click here. We know that paracetamol has a pharmacological is a pharmacologic agent and works as an anesthetic or an analgesic. Here you can see 5 references where paracetamol has been reported with anesthetic or analgesic functionality. So keywords in SPRESI are really not the keywords of the abstract, but really keywords that have been given from scientific abstractors. The same is for physical properties. In this case, we have reports of 11 different melting points for paracetamol, and here again you have the links to the references. We have calculated properties. We have 581 journal articles for that report about this compound. 142 patents. We have also other references. Other references are mainly conference contributions, notes, but also PhD theses can be. We also have an external link to Springer materials. So clicking on this link, we will get at the beginning of the Springer Materials database. We have information stored in Springer Material and in Springer Material documents. And of course, this is a hinterlink, so the same will happen for users of Springer Materials. They will also get information about substances that are also present in SPRESIweb. And finally, here also we have a certain number of links. These are very interesting. For example, paracetamol is reported 208 times as a reactant and 42 times as a product in SPRESIweb. So, of course, this is a hyperlink. As I said, when I click on it, I will go to the reaction hit list that will show me the 42 reactions that have this compound as a product. So many of them, if we get here, for example, here again you can have a look. You can see it's green highlighted, which means it is available at supplier. Also the reactants are, so again we will have the possibility to go to supplier. We can search for this molecule as substructure, as an exact search, as reactant, as product. Just to show you how interactive the user interface of SPRESIweb is. All references that have this symbol have a DOI, which means that the publishers offer the possibility of having a look at the abstract. In this case, you can have a look at the whole first page of the article. Of course, you will have to purchase the full text if you are not able to have a look at the whole paper. So again, also in reaction hits, we have a certain number of links. For example, we can have a look, and we can look for similar reactions to this reaction. Again, I get a hit list of reactions. It's 17 reactions that have a mechanism which is similar to the one that I have chosen and just shown. Okay, this was it for structures. If there are questions, I gather that I will get them at the end of my presentation. Now I would like to concentrate on the reaction search form. You have already had a look at a couple of hit lists. Of course, it looks pretty similar to the molecule search form. Again, here we have a certain number of reaction text search possibilities, such as yield, reaction conditions, author, patent, hit list, and so on. We also have the possibility of performing search as name reaction search. I'll come to that immediately. Of course, again, we can combine text searches. We can include reactions and combine text with reaction searches. The editors are, again, ICEdit, ISIS, and ChemDraw. And everything is pretty similar to what I already showed for the structures. So I can also decide to see a detailed hit list or a compact hit list. I can choose to see the reaction substructure or the reacting centers in my hit list, and so on. For what concerns the search operators, Again, we have an all-in-one reaction search, which combines exact search, substructure search, similarity search for reactions. We also have operators such as contains exact reaction or exact reactant, exact product. Now I would like to show you an example of a name reaction search. This is fully integrated in SPRESIweb. I can tip here the name of the reaction. I can, of course, look in alphabetical order to the different reactions, or I can add, for example, so let me see. What will I be looking for if I say Diels Alder? See if I typed it in the right way, of course. So these are the Diels Alder name reactions possibilities that we have in SPRESI. And for example, I will try to have a carbon intermolecular cycler addition. I would like to combine this name reaction search. There is a certain number of Diels Alder reactions with a substructure. So I will just click here to get a clear screen. For a reaction, I always need a reaction file, and I want that this substructure is contained in my product. So I just transfer the structure and start the search. It is, in this case, a reaction substructure search. And now we are performing this combined search. I have 5 reactions. 5 reactions. This is how a hit or a detailed hit for a reaction look like. Again, we can see in blue highlighted would be the whole substructure here. The red part are the reacting centers. And indeed, we can see that we have here an intramolecular cycler addition. Here is the diene, dienophile, and here we close the ring. We have a certain number of information about the reaction. So this reaction is performed with 94% yield in these conditions. Of course, again, I have a link to the reference, and here I have links to other Diels Alder reactions in SPRESIweb. Of course, it works also other way around, which means if you perform a reaction search and in the hit list you have reactions that have an assigned name reaction, you will get this information in your hit. This can be very interesting. Maybe everybody knows Diels Alder, but we have over 500 different named reactions in SPRESI, and this can be of an advantage in choosing a synthesis pathway, for example. An idea to advance query features, so this would be my last example for a reaction search. I would like to show you with this example how you can reduce or better define a query by performing a reaction substructure search, and how you can refine a hit list. So just let me draw this reaction. It's a quite easy reaction. Okay, I must admit I'll have to draw it now with a hole, but it's of course a substructure, a reaction substructure, and here we go. Here. define a query like this one here, what I actually want to have is to close this ring. Now let us have a look to a compact hit list of 48 hits. And let us have a look to what we have really retrieved with this search. So, as you can see here, the first hits indeed show us the reaction we were looking for. So we close the ring intramolecularly. But here, for example, the ring is already in the reactant, and we are not. Oh yes, of course, here we are again. Let me see if I find an example. Actually, I must admit, I have just performed a mistake in my query because I have looked for an all-in-one reaction search and not for a substructure search. So I will, of course, find all similar reactions that have exactly this mechanism. Let me just perform a reaction substructure search. Just to get to the point, I would like to show you really how can I refine a hit list if I don't find the right hits. Actually, with this mistake that I made in performing the search as an all-in-one search, I have also showed you how the strength of this innovative operator, because I found exactly what I was looking for without having to define specific query features. So here you can see exactly what I wanted to show you before. Here you can see the structure. This was my substructure in the reactant. This is the substructure in the product. But this reaction has not occurred. It's not the reaction I wanted and I was looking for. So to change this, I can just map the reaction. So if I map the atoms in this reaction and tell the program that I want exactly this transformation where these atoms stay the same and where this bond is a make-break bond, and I perform my search, reaction substructure search again, we had 214 hits for my former reaction substructure search. Now you will see that I break down the hit list and I only get 54, I can anticipate it while it's searching, 54 reactions. And indeed, in this case, I have only retrieved the hits I was looking for, so only the cyclization I was looking for. So this is what concerns reaction searching. Now I would only just I would like only to show you another small example of the STS. STS is synthesis tree search, and this is the synthesis planning tool. You have already had a very nice presentation about the InfoChem synthesis planning tool, and you have seen that this is based on an algorithmic philosophy and principle. The STS, the synthesis tree search in SPRESIweb, is based on literature, which means you will only get the possibility of building a synthesis pathway to the target based on reactions that are reported in the literature, specifically in SPRESIweb. To do this, I will just perform a text search. In the basic index, I want to look for 3 I will perform. This is still a classical molecule search. Unfortunately, I still didn't have the detailed hit list, so I'll just perform it again to let you see how do I get to the synthesis tree search. Here you can see this is multistriatine, and I want to synthesize exactly this compound. Then I will click on STS, choose the molecule, and say I want to look for all the reactions that contain this product. And I'll perform a search. I get 2 reactions. Of course, if I click here, I will go to the detailed hit, so what you have normally in the detailed hit list for reaction. And clicking on the molecules, I can add the molecules to the tree overview. This is, for example, what I'm doing now. I want to build a tree in order to get a tree and to have only commercially available products as starting material. So if I want to have a look at the tree, this is how it looks like. So I can click again and choose again all the synthesis reactions. Again, I will add the molecule to the tree overview. And again, have a look. This was not commercially available, so I will expand also this branch and add the molecules to the tree overview, and so on. So I can perform these steps on and on and on until I get to only to commercially available starting material. At the end of the tree, when I've built, for example, here I can look for, I have 4 reactions for these compounds, but now let me stop. Of course, I can choose, for example, to have a look at the path to the target. And again, here I will get a list of all the steps that I have to perform to synthesize my target molecule. And again, here I can go to the details and have a look at the reaction. I will go back, of course, in a detailed hit list for this reaction. Okay, so this is what my live presentation looks like. So I log out. I'm getting out of the program now, back to my presentation. And here I only have one slide to summarize what SPRESIweb offers to the user. It is a web application, so you access this from any PC. We perform the updates. You only get the new version. We offer advanced structure and reaction search possibilities, maybe to highlight the all-in-one search operators for structures and for reactions, and also the similarity search for reaction, which is based on the InfoChem classify algorithm, the name reaction search, which is integrated in SPRESIweb, and we also have the synthesis planning tool, STS. I haven't showed, but you can try it out. we can also export sets of data, SSD and RD files, PDF, and so on. So, thank you very much. And yes, if there are questions, I will be happy to try to answer them. Thank you very much.
Thank you very much, Valentina, from InfoChem for that overview of SPRESIweb. So if there are any questions, could you please put those into the questions module of the GoToMeeting software? And in the meantime, just remains to thank Valentina for that excellent webinar, and also remind attendees of the next webinar in the CDS summer webinar series, which will be of Chemicalize by Chemaxon on the 13th of August. And this can be found, registration link can be found on the chemical database blog. So we do have a question for you, Valentina.
Yeah.
So I think that SPRESIweb is a tool for the organic chemists. Is there much of an application in materials chemistry, would you know?
Well, actually it is really with focus on organic synthesis, not only organic chemistry, but really organic synthesis. So also on reactions, even more than on structures. This is also the reason why we created this partnership with Springer and have links to Springer materials, so that if there is something that can be also researched in Springer materials, then you can have, if you have the possibility, just have a look on that site. It is not really for materials. It's not a database that is thought for materials.
Okay, thank you. Have we got any more questions from attendees? How well does SPRESIweb deal with organometallic reagents? Are those covered at all?
Again, same answer as for the materials. It's really organic synthesis, the organometallic, of course, with the catalysts, a certain part, but mainly it doesn't. It's really hardcore organic synthesis, I would call it like that.
Yes. Okay, thank you. I don't think we have any more questions. So this webinar will be uploaded onto YouTube, and we'll publicise that via the CDS Twitter feed and the Chemical Database Service blog. So it just remains to thank Valentina from InfoChem for presenting this overview of SPRESIweb, and thank you to all the attendees as well. Thank you.
Thank you very much.